Here we go. Our objective for today, I can evaluate and graph radical functions. I can evaluate and graph radical functions. Read it together. 1, 2, 3. I can evaluate and graph radical functions. So this is our first lesson of the last chapter of this text. Okay, and we already saw some radical expressions towards the beginning of the year. Today we're going to be looking at radical functions. Okay. We're going to do two different things. Evaluate, we already know how to evaluate expressions. And we're going to graph, we already know how to graph. But there's a couple of things that we need to have in place. So with that said, copy this down. We need the Fourier model. So what are radical functions? Radical functions. Radical functions are a function whose rule contains a variable under the square root sign. Yes, the Fourier model, you need it. A function whose rule contains a variable under the square root sign. Radical functions. A function whose rule contains a variable under the square root sign. Examples. Y equals square root of x. 8 times square root of x equals y. Y equals square root of 2x plus 1. And y equals 3 times square root of x over 2 minus 6. Copy those. Okay, once again, radical functions. A function whose rule contains a variable under the square root sign. So, really quick, pens down, eyes up here. Let me go over the examples according to the definition. It says, a function. Okay, we have functions here. Remember that when we got to functions, I said you can either write it as f of x or you can just substitute the f of x for y. Is that correct? Do we have it equal to y? Yes, here it is, here it is, here it is. So they're all functions. But the rule contains a variable under the square root. So first of all, do we have a square root sign? Yes. Does it have a variable inside? Yes. Does this one have a square root sign? Yes, a variable. Square root sign, variable. Square root sign, variable. So two things need to be met. And it has to be a function, and there has to be a variable under the square root. So let's see. Let's look at our none examples. None examples. We got square root of x. Y equals x plus square root of 16. And negative 3 plus x equals 10. Copy those and start thinking about why are these non-examples. If these are the examples, why are these non-examples? Copy those, please. Think about it as you're writing them down. One thing that we saw, number one, this one is not a function. It's not equal to y. This one, there's no variable under the square root. And this one does not have a square root. So important things to remember, it has to be an equation. Is that correct? And it has to have a variable under the square root. So make sure you write those as your critical attributes. It has to be an equation. And it has to contain a variable under the square root sign. Okay? Okay. Steps. We have 4 steps. Step number 1. To evaluate. Step number 1. To evaluate. Comma, substitute values for x and simplify. To evaluate, 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 substitute values for x and simplify. What do you do when you evaluate?
Substitute value for x.
All right, so pretty much to evaluate, the easiest thing to remember is that we substitute values and at the end we simplify. Step 2, to graph. To graph. The very first thing we need to do, identify the domain. Identify the domain. I'm going to show you how to do that. To graph, identify the domain. That's step 1. To graph, identify the domain. From there, we use the domain to build an input-output table. Build an input, I'm going to circle build an input-output table, but using the domain. And number 4, pretty much we just graph by plotting our points and graphing our function. Okay, copy that. Okay, so 4 basic steps, but there's 2 different things that we're doing today. Number 1, we're evaluating, the other is graphing. So to evaluate, we already know we just substitute values for x and simplify. To graph, we need to identify the domain, build an input-output table, and graph. We already know how to do most of this stuff, okay? So here we go. So to get us started, copy this example down, example 1a. It says, copy this down, the function y equals 8 times square root of x gives the speed in feet per second of an object in free fall after falling x feet. Find the speed of an object in free fall after it has fallen 16 feet. Yeah, you only write the black text. Go. All right, here we go. So if you notice on this one, they're asking us to find the speed of the object. Are they asking us to graph? Are they asking us to graph? No. And what did we say we were doing today? 2 things, evaluate and graph. So if they're not asking us to graph, then what are we going to do? Evaluate. So you're going to write your function. Let's write the function. Let's do this one together. Y equals 8 times square root of x. However, instead of x, do they give us a value for x? It says, an object is free falling after it's falling so many feet. So many feet is x. Do they give us over here how many feet it's falling? 16. So instead of x, what am I going to write? 16. Bring everything else down. Y equals 8 times the square root of 16. What is the square root of 16? 4. So what is 8 times 4? 32, and that is, and let's see, gives the speed in feet per second. So we need to write feet per second.
That's it?
And that's it. You write your statements. The object speed is 32 feet per second. Everybody got it? Pretty simple?
Excuse me, graphing the
No, there's not.
Yes, there is. All right, here we go. So on this one, we only evaluated, so that means we only substituted a value in there. Is that correct? Okay. So that's one type of example that you're going to see. Let me show you another one. Everybody look up. Copy this one down. Example 1b. Example 1b. Copy this, please. You don't have to copy the text. Just copy the information that they give us, which is the function and how many feet. Let's see. Let's see if you can set that one up, please. And I'll work this one out together. All right, so let's see. Who noticed the different part on this one? The function's the same. Y equals 8 times square root of x. But instead of x, what are we going to substitute? 20. So this becomes y equals 8 times square root of 20. So therefore, y equals 8 times a certain number. Since this is not a perfect square, we know how to get the decimal form, don't we? Let's see, I'm going to refresh your memory. Square root of 20 falls in between square root of 16 and square root of 25. Remember that? Remember that? All right. So therefore, if square root of 20 falls in between here, what is square root of 16? 4. So this could not be more than 5, but it has to be more. It has to be more than 4, but not more than 5. So it's 4 point something. Let's find out. Let's find out if it's 5. What is 20 minus 16? 4. What is 25 minus 16?
Is that negative?
9. So now that we have this fraction, do we know how to find the decimal?
Yeah, divide the denominator.
4 divided by 9. That becomes 0, add a 0 at a decimal. That's 4, that's 36. Subtract, that's 4. It's going to repeat, so it's bar, so this is 4.4. So this is y equals 8 times 4.4. And we just multiply. Let's see. 8 times 4, that's 32. We got 3. 8 times 4, that's 32 plus 3, 35. So the following object is going at a speed of 35.2 feet per second. Yes? All right. So just to emphasize, you see the two different types of numbers that they're going to give you on the homework. We have one that has a perfect square, a squared number that you can take the square root of 16, right? It could be maybe 25, 36, 49, 64, 100, 100. Does everybody see what I'm saying? However, you're also going to get some of them that are not perfect squares, like this one. That's when you need to do this piece and find the decimal form. Are we there? All right. So that's the first piece, to evaluate. Now we're going to get into finding the domain in order to graph. That's the piece that you need to know in order to graph. Okay? So with that said, here you go. Pay attention, please. I'm going to show you a couple things. Example 2A. You're just paying attention right now. Pens down, please. Eyes up here, pens down. Check this out. I'm going to write here square root of 16 or your square root of negative 16. I'm going to skip a line and I'm going to write square root of x and square root of, y equals square root of x. Okay? So everybody look up. I'm focused on this one first. Square root of 16 is what?
4.
4. Okay? However, square root of negative 16 is not.
I knew it.
Why? At the beginning of the year, the very first thing I told you, the first week that we met, there are no such things in Algebra 1 as negative square roots. These are known as
51.
Imaginary numbers. Remember that?
Fake one.
Does everybody remember that?
Yes.
So any negative number that I substitute in here becomes a what? Imaginary. That's what we cannot find the square root of. Are we there? So what am I saying? That any negative number cannot be found. However, any positive number, what? Can be found. But not only positive numbers, could we find the square root of 0? Yes, what's square root of 0? 0. So therefore, which are the only numbers that we cannot find? And the ones that we can are from 0 and all positive. Another way of saying that, everybody look up. If I was to substitute any value in here, we said we cannot include negatives, but we can include what? Positives and 0. So, think about it. X could be, think about this, greater than or equal to. Let's see. Think about the number line, picture it in your brain. X could be greater than or equal to. What numbers could we substitute in here by what I just explained here? X, what numbers can I substitute in here? Think about it. Okay, tell your neighbor and explain it to your neighbor why. Why is it that you're saying that? All right. Who said X is greater than or equal to 0? That is correct. Why? Because we can substitute, can we substitute 0 in here? Yes, because square root of 0 is what? 0. And it says X could be greater than, what numbers are greater than 0? 1, 1.1, 1.2, any number all the way to the right. Is that correct? So therefore I can substitute even 23. Everybody with me?
Yep.
So any number or all real numbers greater than 0. Are we there? So by that, if I was to give you a function, or we look up like this one, and I ask you to find the domain, all you have to do is take whatever's inside the radical and set it greater than or equal to 0. So my domain for this one is x is greater than or equal to 0. Are we there? Does everyone understand why it's the domain? Because the values of x, let me show you with a number line. The values of x could be from 0 all the way this way. Can we include any negatives? No, because it becomes a imaginary. That's why my domain is x greater than or equal to 0. Copy that, please. All right. Everybody got this? All right. Yes. Let's go ahead and copy this one down. Example 2b. Example 2b. Copy these down, please. 2b. And just write, find the domain. Find the domain. You're going to write capital A is y equals 1 plus square root of x minus 4. And B is y equals square root of 4 times x plus 3. Copy those two, and let's do these together. So here we go. We're going to find the domain for this one. Domain. So, what did I say that we were going to do to find the domain? Write whatever's inside of the radical, x minus 4. Is that correct? Is that inside of the radical? And write greater than or equal to 0. And let's just solve and see what our domain is. So plus 4, x is greater than or equal to 4. So if we were to picture the number line, what's my domain starting at what? At 4 and everything to the right. Everybody with me? Does everybody see it? Okay. Let's look at this one. Domain. Do that one by yourself, see what you get, and then I'll go over it. Okay, let's see. First things first, what's inside of the radical? 4 times x plus 3, and all that is greater than or equal to 0. Okay, let's solve. Divide by 4, divide by 4. X plus 3 greater than or equal to 0. Then at the end, subtract 3, x is greater than or equal to negative 3. So what values can I substitute in here? Starting at what? Negative 3. And some of you, your brain's probably your brain's probably playing tricks on you, and you're saying, Mr. Q, I thought you said we couldn't make this negative. And here's a negative 3. No, I said the radical, the value inside could not be a negative number. Is that correct? But the values that we can substitute for x, we can find them by setting them greater than or equal to 0 in order to find our domain. So if I was to substitute this first number, negative 3, let's see. What is negative 3 plus 3?
0.
So what is 4 times 0?
0.
What is square root of 0? So y is equal to 0. Technically, yes. But for right now, we're going to focus just on these. We substitute negative 3 plus 3, and so on and so forth. All right, so now that we got the domain, that's the first step we need in order to graph. So copy this next example. Here we go. It's really quick. All right, so looking at the function, from now on, radical functions, this is how the graph is going to look like. It could either start here, there, 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 here, here. But in what direction is it always going? To the right. Right now we're only working with positive radicals. Are we there? All right. So with us looking at it, Everybody look up. What is my domain? Don't say it out loud. What is my domain of this function right here? What is my domain? Who sees that it starts at 0? Is that correct?
Yeah.
And it's all the way to the right, so this x is greater than or equal to 0. What is my range? My range is my y values. Think about it. Where does it start? 0. So my range for this one is y is greater than or equal to 0. We got it? All right. Last problem. Here we go. Copy this one down, please. Example 3a. We did most of the work. This is the one that I want to show you in regards to how to graph it. Okay?
Okay.
Okay, here we go. So it says graph y equals square root of x minus 3. So here are the steps that you need to take in order to graph. So for those of you that were like falling asleep or your mind is somewhere else, pay attention. This is the piece that you need to understand. Here it goes. We take whatever's inside of the radical to find the domain first. That's the first thing we need to find. So what do? X minus 3 greater than or equal to 0. And let's solve. Plus 3 plus 3. X is greater than or equal to 3. That's my domain. That was step 1. Step 2, we need to build an input-output table. Input-output table. I'm going to do it over here. X, Y. And what is my domain for this one? Everybody with me?
Yeah.
Starting at what? At 3. And we go to 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Now, why didn't I use anything less than 3? Because the domain is what?
3.
Greater than or equal to 3. Are we there? So let's fill out our table. Do we know how to fill out this table? Yes. Let's evaluate each of the values. What's my first value?
8.
3. So that goes here. Y equals square root of 3 minus 3, which equals to what?
Yeah.
3 minus 3.
Yeah.
So square root of 0 is 0. So this is 0. And let's plot each point as we get the point so that we can see what we're doing. So my first point is 3 of x, 0 of y. 1, 2, 3, and 0 of y is right there. So far so good? Next one, my next value. It's 4. So what is 4 minus 3?
1.
Square root of 1 is 1. So 4 of x, 1 of y. There it is. See how it's starting to come this way? All right. Next one, 5. So this is square root of 2. You're saying, oh no, Mr. Kid. Not a perfect square. Does everybody see that? Who wants to do a lot of those? Who wants to do only perfect squares? Here, let me show you a trick. Here it goes. Here goes the trick. Everybody look up, please, or you're going to miss it, and you're going to have to do all those little ones. Here it goes. This is what you set up. Square root of blank minus 3. And think about it. What would be the next number of these that I substitute in here that gives me a perfect square number? Let's see. 5 gives me 2. 6 gives me... Hold on. 6 gives me 3. 7 gives me... What is square root of 4? 2. So the next number that you would like to substitute is 7. So 7 is square root of 4, which is y equals 2. So therefore my next point is 7 of x, 3, 4, 5, 6, 7, and 2 of y. And do you see the curve going this way? At least if you can give me 3 to 4 points, we're good with that. And what I'm saying is that, yes, you may skip this one, and you may skip that one if you want. Everybody got it? All right, so homework for tonight is on page what? 702, numbers 1 through 19 odd. Have a good one, guys. Enjoy your homework. I'll see you guys tomorrow.